Good morning, class. I apologize I wasn't able to put in this video yesterday, but I am doing it today. This assignment is due tomorrow. I probably will assign another assignment today, which means it won't be due to probably next week, probably like midweek, like Wednesday. So I had a couple of questions like on problem number 3, and then I had a question on the other page, 13 and 14, those big problems. You guys got to think out of the box. I'll try to help you as much as possible. I'm not going to give you the answer. The answers are already there. I'll try to help you with the process. For number 3, it's very similar to number 2. Notice how number 2, they give you the diameter of that great circle, okay, which means it's the hemisphere cut. You have your diameter of your sphere, so what you need to do is to find the radius. You have to cut the diameter in 2. That means your diameter is 11 divided by 2 ends up being 5.5. So now your radius is 5.5. So all you have left is, this is a volume problem. So volume is 4/3 pi r cubed. 4/3 pi times 5.5 to the third power. This would do, let's use our calculator. We're going to use 3.14. That's what I'm using for these answers you have there. So if you're using an actual scientific calculator, you're gonna have a different answer, you know, several units off, but it's going to be pretty close. So 5.5 raised to the third power times 4 divided by 3, you're going to get roughly about 221.83 pi, and if you do that times 22.83 times 3.14, you're going to get 696.56 yards to the third power. Alright, we're moving on to number 13 on your homework. That's 13 right there. 13 is super similar to your notes on number 9. Notice on both of these, you have to figure out, like, what are they asking for? What's the final question? Well, the final question is they want the volume of a sphere here. Okay, for number 13, they want the volume of a hemisphere. So you have to know what equation you're dealing with. For number 9, you're dealing with 4/3 pi r cubed. For number 13, you're dealing with not 4/3, you're dealing with 2/3 pi r cubed. Okay, so both of these, we're going to need this guy, the radius. Alright, so the problem with this is they don't give us a picture, they don't give us a diameter or a radius. What they do give us is this area thing. Alright, they give us that area right there for number 9, and they give us this circumference for number 13. Both of these you're going to work exactly the same. For number 9, they give us the area of the great circle. That means they're giving you the area of a circle. You remember area of a circle? Pi r squared. That is your equation, right? Alright, so you have area of a circle. If we look at this equation, they give us the area of the circle. They give us 201.06. We know the formula is pi r squared. We're reversing the formula. We want to find out the r. Well, 201.06, we have these two multiplying each other. That means I'm going to have to divide by pi to get, well, an answer. So let's divide, and I'm going to use 3.14. 201.06 divided by 3.14. Some of you will divide by pi, and that's completely okay. I'm going to round to the nearest hundredth. So this gives me 64.03. These are crossed out. I'm left with r squared. How do I get rid of a power of 2? To get rid of a power of 2, we're going to have to square root both ends. If I square root 64, well, most of you know already the perfect root of 64 is 8, so your answer is going to be roughly 8. So let's see, what do I get? 8.00001. Ooh, guess what? This becomes 8.00 is my radius. Yes. So here is my radius. Notice that's what they did there. I'm just showing you step by step, and they plugged it into the formula. This answer right here is using a scientific calculator. That means they used the the irrational number of pi. So if you use 3.14, you will probably get a different answer than this example right there. Let's see what they would have gotten if they used just 3.14. We're looking at 2048 divided by 3 times 3.14, 2143. So if you're doing it just with a regular calculator without pi, you're going to get roughly this. Okay? So, for number 13, they're giving you circumference. So, hemisphere, that's my volume. So in the end, once we get our answer, you're going to plug it into r cubed and do the rest. But before you do that, you need to get the radius. Well, they're giving you circumference, so you need to remember, what is circumference of a circle? Well, circumference of a circle, and this is where I'm going to stop. I'm giving you the equation already. Circumference of a circle is 2 pi r. It's also pi times diameter, but we don't need diameter, we need radius. So 2 pi r, that is your equation. You're going to have to substitute that there, and then continue to solve for radius. Once you get him, you plug it in to that one. Similar to what I did to number 9. Alright, we're working on number 14 now. I'm just going to give you the formulas. You guys have to do the math, alright? They're talking about a hollow sphere. Sits snugly, which means it touches the walls of the cube. So that it tells you it's a foam cube, so that the sphere touches each side of the cube. Find the volume of the foam. Alright, so if we're going to find the volume, that means we're going to do a subtraction problem. We know that we have this box, this cube, and it has a circle cut out inside it. So we need to get rid of that circle. That's our problem. We have the big cube. The cube is the big stuff, and we got to take away the circle. So we got to find this here. This is all the stuff that I want to know. That's what I want to know. That's the volume. So we need a subtraction problem. So we need the volume of the cube. Well, from your previous lessons, we know that the volume of a cube is side times side times side, or side cubed. We're going to take away the volume of the sphere. And we know the formula for that is 4/3 pi r cubed. So, if we look over here to the side, for the cube, we need to know side. Do we know side? Oh yeah, it's right there. It's 18. So finding this won't be too hard. I'm going to let you figure that out. finding the volume of a sphere, well, 4/3 pi r cubed, we need our radius. So if we look at our picture, you know that the sphere touches the walls of that cube. So what does the distance from wall to wall of the cube tell you? What is that? Okay. Let's see if the light bulb clicks on you. No, I'm not waiting for an answer because this is a recording. Duh. If this is the distance from here to here, that means that's the distance from there to there. That is what is called your diameter. I am going to leave it there, and I'm not going to proceed to give you the rest of the answer because you should be able to figure it out from there if you know the diameter of a sphere. You can get the radius, and then you can plug it in, then you can do the subtraction, and voila, you have your answer. Merry Christmas. Stay tuned to your lesson for today. Bye, Felicia.